ಹೌದಾ? ಹೌದಾ? ವಾಯ್ಸ್ ಅದು ಕೇಳಿದ. Hello? Hello all, this is Indra. Jananishri, hi. Am I audible? Are you able to hear me, Jananishri? Jananishri, am I audible? Mohammed Haji, hello. Am I audible? Can you please drop the replies in the chat box, please? Am I audible? Yeah, thank you, Mohammed, for your response. Yeah, Raj Singh, hello. So, good afternoon, all. Derek Prince, yeah, hello. Pratham, hello. Okay. So, I warmly welcome you all to this free webinar on embedded systems in association with Dr.D.Y.Patil, Institute of Engineering Management and Research, Department of Artificial Intelligence and Data Science. So, today we are going to learn about the topic on embedded systems. So, let's start the session now, okay? Okay. So let me give you an overview of this embedded system before getting into the actual topic, right? So in our daily life, we have seen so many electronic gadgets and so many electronic equipment. So in which equipments or in which devices embedded systems are used, that we have to know, right? So in personal computer systems, we are not using embedded processor. We are only using general purpose processor. And if you are seeing television, microwave oven, cameras, washing machine, so in all these equipments we are using embedded systems. So before going to the overview of embedded systems, let's first know the two basic things. One is embedded, another one is system. So what actually do they mean? Do you have any idea about what is embedded and what is system? Do you guys have any idea about that? What is embedded And what is system? You can just drop me a single line answer. What is embedded system? So let me tell you that, okay? So now let's see. First, what is a system? See, a system is an arrangement in which all its components assemble work together according to a set of rules. So we will say systematic approach, which means they are following a set of rules or set of equipments, or all combined together, work together to perform an operation that you called as a system. So it can also be defined as a way of working, organizing, or doing one or many tasks according to a fixed plan. For example, a clock. So it is a time displaying system, right? So its components follow a set of rules to show time. If one of its parts fail, the clock will stop working. So we can say in a system, all its subcomponents depends on each other. This is what system is. Okay. See, now what are embedded system? An embedded system is a system that has software which is embedded into hardware, which makes a system dedicated for a specific task. So, embedded means something which is attached or like integrated to another thing. So, it is a combination of hardware and software, in which the software embedded into hardware, and it is designed to do a particular task. So the task has to be completed in a given time. This is the main constraint that you called as an embedded system. So an embedded system is a microcontroller or microprocessor based system. So it is not like a general purpose computers. These are the embedded systems which may work independently or attached to a larger system to work on a specific task. So let's see some examples, then you will get a clear idea about it, okay? So see, examples of embedded system. So embedded system applications appear in every industry and sector today, right? So embedded devices and software play a crucial role actually, like functioning of cars, home appliances, medical devices and other equipment we use in our daily life. So if you look around, you can actually see a lot of embedded system examples. Nowadays a lot of things are being designed based on this embedded system. So let's see some real life examples. Okay, so first one is GPS system. It is a navigation system, right? So that uses satellites and receivers. Satellites and receivers for what? To synchronize data, which is related to location, time and velocity. And the receiver, or you can call it as a device that receives the actual data. So the embedded GPS device allows people to find their current locations and destinations easily. Generally used in cars, mobile phones and so on, right? So fitness tracker. So these are wearable devices that can monitor your health and track activities like sleeping, running and walking. So these devices use embedded systems to collect data related to your heart rate, related to your body temperature and the number of footsteps, which is further sent to servers via WAN like LTE or GPRS like that. So fitness trackers are generally used for what? Like monitoring personal activity, medical monitoring and sports training and so on. And there is a thing called ATM. It is a computerized machine used in banking that communicates with the host bank computer over a network. And the bank computer verifies all the data entered by the users and stores all the transactions, right? While the embedded system in the ATM displays the transaction data and processes input from the ATM keyboard. And at last there is a best example of this embedded system, which is home and office security system. So home and office security system contains a network of sensors, cameras, alarms and other embedded devices so that gather information about a building's interior and as well as exterior. and use it to what? Alert the users. We can also take mobile embedded system like small portable embedded devices like cell phones, laptops, digital cameras, smartwatches, calculators and so on. There's a lot of things which has embedded systems. So now let's see main components of embedded system. Actually, the embedded system mainly consists of these three components, which is hardware, software and RTOS. This is the three main things. First, let's talk about this hardware. So, an embedded system uses a hardware platform to perform the operation. So, the hardware of the embedded system is based around microprocessor and microcontroller. It has the elements such as input-output interfaces, memory, user interface and the display unit. It is not a general purpose system, right? So, you don't need to put every hardware to the system. So, generally the hardware components can be memory, it can be power supply, processor, timers, input-output circuits and serial communication ports. You can include all these things, right? And software. So now coming to the software, it only requires this hardware which is needed to perform that specific operation, or you can call it as application. So this application software allows the user to perform varieties of application to be run on an embedded. That's what you call as software. And the main thing which is RTOS, which is real-time operating system. It is another important component that is present in an embedded system. So see, when a system is finishing its task and send its service on time, then only we can set it as a real-time operating system. So that are real-time operating systems, mainly it is doing the function of coordination between hardware and software. So now a question arises in our mind that why we are going for real-time operating system? Why? Because if you take the case of automatic washing machine, here there is a lot of importance to time. At this time interval, the washing machine should be completed. I mean, the washing should be completed. Or within this time interval, the draining should be completed. So likewise, there is actually a lot of importance to time. If you take most of the embedded systems, time is actually a very critical thing. If you miss the time limit or the deadline, the functioning of the embedded system will be completely disturbed. So now the main difference between a real-time operating system and a non-real-time operating system is that in real-time operating system, they are giving more importance to deadline. If that deadline is missed, the performance of the system will be very much affected. So that's why we are going for RTOS, while in non-real operating system, we just neglect the time deadline. So now let's see characteristic of embedded systems. So what are they? First one is perform specific task. So embedded system performs some specific task or functions. Low cost. So the price of an embedded system is not so expensive and time specific. It performs the task within a certain time frame. Low power. It doesn't require actually much power to operate. It only requires low power. High efficiency. The efficiency level of embedded system is so high. Minimal user interface. So these system requires less user interface and very easy to use. Less human intervention. It requires no human intervention or very less human intervention. Manufacturable. The majority of embedded systems are compact and affordable to manufacture, and they are based on the size and low complexity of the hardware. And microprocessor and microcontroller. It can be either microprocessor based or microcontroller based. Actually, both are integrated circuits that give the system compute power. So next, basic structure of embedded system. So there is the first thing called sensor. So sensor helps you to measure the physical quantity and converts it to an electrical signal. and it also stores the measured quantity to the memory. So this signal can be read by an observer or by any electronic instrument such as like A to D converter. And this A to D converter converts the analog signal sent by the sensor into a digital signal. And then comes to this memory. It is used to do for what? Store information. So embedded system majorly contains two memory cells. One is volatile and another one is non-volatile memory. Volatile means volatile memory store data and computer programs that the CPU may need in real time, and it erases them once the user switches off the computer, like cache memory and RAM, that are the types of volatile memory. On the other hand, non-volatile memory, which is static, it remains in a computer even after a user switches it off. So this is the difference between volatile and non-volatile. And then processor and ASIC. ASIC is nothing but application specific integrated circuit. So processor process the data to measure the output and store it to the memory. So ASIC is nothing but an integrated chip which is designed for a specific purpose. For example, you can take a toy bear that contain a chip for talking purpose. So it handles the interface between memory and microprocessor. And then converter, digital to analog converter. This converts what? Digital data fed by the processor to analog data. And then at last there is a thing called actuator. So actuator compare actual output to memory stored output and choose the correct one. So the sensor reads external inputs, then the converter, which is nothing but ADC, which makes the input readable to the processor, and the processor turns that information into useful output for the embedded system. So this is the basic structure of embedded system. So now let's see the advantages and disadvantages of embedded system. So first let's talk about the advantage. It is versatile because of smaller in size, faster to load, easy to manage, low power consumption, low cost, dedicated to only one system and spend only less resources. So what are the disadvantages? It high development cost. The upgrade is difficult. Troubleshooting is difficult. If any problem occurs, then you need to reset the whole settings. So larger time to market. These are the advantages and disadvantages of embedded system. So now let's jump into the important topic, which is microprocessor versus microcontroller. So processor is the heart of an embedded system, right? It is the basic unit that takes input and produces an output after processing the data. For an embedded system designer, it is necessary to have the knowledge of both microprocessor and microcontrollers equally. So see, here let's talk about the microprocessor first. So what is microprocessor first of all? It is also called CPU. This is the main part of the computer which performs all the operations. It is the brain of the computer. Everything is done by processor, just like a human brain. If our brain is dead, we can't do anything, right? Because brain is sending every information to other parts of the body. So the same way, the processor is also called as brain of the computer. It is a single chip which is capable of processing data. Yes, of course, it is a single chip which is present inside a computer. So inside a computer, there is a motherboard. So inside a motherboard, there is a single chip which is called microprocessor. It is all components in the computer. So in the computer, we are having so many components like memory device, monitor, input-output devices, USB ports and so on. So we connected these components externally to the computer. So these are all controlled by processor. It executes instruction. So whatever the data the user is giving, it will be executed in the sequence of instruction one by one. And at last it fetches, decode and execute the instruction. Fetch means taking. So fetching the instruction from other devices or other components of the computer. After that it's decoded, which means whatever we are giving, it's just an English type language, right? It means C, it can be C++, Java. So it converts it into a assembly language, then into machine language. Machine language is nothing but binary language, which is zeros and ones. At last it executes the instruction. So now let's see. This is what actually present inside the microprocessor, right? So inside a single chip there is three things: timing and control circuit, ALU, register. So exactly what these three will perform. First one is register. So register is nothing but a temporary storage location, which means data will store temporarily, not permanently. Whenever the processor executes the data, will erase. And ALU, you already know this, I think. It performs all the arithmetic and logical operations, which means all the mathematical calculations are done by ALU. And timing and control circuits. So it keeps all the other part of the system. So whatever the part of the system that is present outside the chip, like memory, registers, ALU, input output devices, which is working together in the right time sequence. So whether they are performing the operations in right timing or not, that will be checked by this timing and control circuit. So up to now we have seen just what the things that are present inside the processor. Now let us see microprocessor is connected with which components outside. What it is? Input, output, memory. So input is used to give input data to the microprocessor, and output will use to provide the result. So whatever the result, it will be displayed on the screen and stored in the memory. And memory is for what? It is used to store the data. It is a bidirectional. It accesses an input to the processor as well as the output to the processor. Suppose the processor want to do some operation, in the sense it fetches the data from memory and performs the operation, and again it stored it in the memory, right? So these are all the functions of each and everything. So now let's talk about the other important thing, which is microcontroller. See, microcontroller is an integrated electronic computing device that includes three major components on a single chip, that is a whole microprocessor, memory and input output ports. So see this slide. See, so microprocessor unit means it consists of ALU, registers and timing and control circuit. So whereas the microcontroller means the complete microprocessor is present inside. Along that you are having a memory, input output ports integrated in a single chip, that we call as microcontroller. And some devices are also supporting this chip. Those are timers, ADC, serial ports and other devices. It also having some common communication line. So these are not just an arrow mark, these are called communication lines. So these lines are called as buses. So all the components connected with the help of these buses. And a system bus is divided into actually three types. One is address bus, data bus and control bus. So what is the purpose of address bus? So address bus is used for, it will tell you that where we have to get the data and where we have to put the data. And then data bus, it consists of what type of data is to be transferred from one component to another. And then control bus, which is used to control these data to transfer to that particular address. So now, what is a microcontroller? A microcontroller consisting of three main components that are integrated in a single chip. So the three main components that are present inside the microcontroller are microprocessor, memory and input output devices, along with the supporting devices like ADC, timer, serial port and other things. Okay. So which are communicating using this communication lines, which is nothing but buses. So this is what we call microcontroller. So now see this microprocessor versus microcontroller. Let us see the difference between both. Okay. So microprocessor is the heart of the computer system. So microcontroller is the heart of an embedded system. It is only a processor, so memory and input-output components needs to be connected externally. If you are seeing microcontroller, it has the processor along with the internal memory and input-output components. So memory and input-output components has to be connected externally. So of course the circuit becomes large and the cost of the entire system is also high. But here everything is already present inside, so the circuit is also small and the cost of the entire system is also low. So due to external components, the power consumption is also high, but in this case power consumption is less. It is mainly used in where? Personal computers. Microcontroller is mainly used in washing machine, MP3 players and whole embedded system. And microprocessors are based on one Neumann model. These are based on hardware model. I will tell you what is one Neumann and hardware architecture in the later slide. Okay. So here it has no RAM, no ROM, input output units, timers and other peripherals on the chip. But here it has a CPU along with RAM, along with ROM and other peripherals embedded on a single chip. So here it uses an external bus to interface to all these things, right? So it uses an internal controlling bus. And the last point, which is it is used for general purpose applications that allow you to handle lots of data. And here it is used for application specific system. So these are the difference between microprocessor and microcontroller. Both work in a great way depending upon their performance and depending upon our needs. Okay. So now let's move to the next topic, which is architecture of embedded system. So typically embedded system mainly has two parts. Okay, one is embedded hardware, another one is embedded software. So embedded hardwares are based around microprocessor and microcontrollers. Also include memory bus, input output controller. Whereas if you are taking about this embedded software, it includes embedded system, embedded operating system, different applications and device drivers. So basically there are two type of embedded system architecture. So whatever the processor you are taking, whatever the microcontroller you are taking, the complete embedded system architecture categorized into two types. One is hardware architecture, another one is one Neumann architecture. So architecture of the embedded system also includes sensors, ADC, DAC, memory, processor, actuator, etc. So let's see what it is. So first one is one Neumann architecture. So see, a computer architecture that uses a single memory unit within which both data and instructions get stored is known as one Neumann. So whatever the data and the code that we want to store or we want to access in embedded system, that data and that code lies in the same memory block. That is referred as the one Neumann architecture. There are three major components that constitute this architecture, which is the CPU, memory unit and input output interface. As I told earlier, data and instructions both reside in a single memory unit. Hence, a single set of bus is used by the CPU to access that memory. In this architecture, one data path or data bus is exists for both data and instruction memory. Whether the bus can be a data bus or control bus or address bus. So that only one bus is used for both data and instruction. As a result, what will happen? CPU can perform only one operation at a time. So that it is either fetching data from memory or performing read-write operations on data. So any operation can be done at a time. This is called one Neumann architecture. If you are taking hardware architecture, here see a computer architecture where the memory unit is divided into two parts for individually storing data, and instruction is known as hardware architecture. Here the data and code or instruction lies in a different memory block. That is referred as hardware architecture. That is a separate memory for program and separate memory for data. So this means unlike a one human architecture, here data memory and instruction memory is in separate format. But as here two separate memories are used, thus separate buses are used for data transferring and instruction fetching. So execution speed is very much faster than one human architecture. So now there is another two architecture, which is RISC and CISC architecture. See, instruction set or instruction set architecture is the structure of the computer that provides commands to the computer to guide the computer for processing data manipulation. So what does instruction set consist of? It consists of instructions, addressing modes, native data types, registers, interrupt, exception handling, and memory architecture. And this instruction set architecture can be considered as a boundary between the software and as well as hardware. So, classification of microcontrollers and microprocessors can be done based on the RISC and CISC instruction set instruction set architecture. Now let's talk about in separate form. Okay, so first one is RISC architecture. RISC is nothing but reduced instruction set computer architecture. It is designed to reduce the execution time by simplifying instruction set computer, which means it is to make hardware simpler by using an instruction set composed of a few basic steps for loading, evaluating and storing operations. Just like a load command will load the data and store command will store the data. And RISC microprocessor have fewer instructions. They have simpler circuit, which means they operate faster. Additionally, RISC microprocessor have more registers, use more RAM and used fixed number of clock cycles to execute just only one instruction. You can also call this as load or store architecture also. So where it is mostly used? It is used in portable devices like Apple iPods, smartphones and tablets and so on. So now let's talk about the CISC architecture. It is designed to minimize the number of instruction set per program and ignoring the number of clock cycles per instruction. In this architecture, a single instruction will do all operations, like multiplication command will do stuff like loading data, evaluating data and storing data. Hence it's complex, right? So complex instructions are made directly into the hardware. The name itself you can find out that complex instruction set computer architecture. So it is more complex and slower. It uses little RAM, it have more transistor, have fewer registers, have numerous clock cycle for each instruction and have a variety of addressing modes. So where it is actually used, it is mostly used in laptops and PC. So at last, let's talk about the characteristic of RISC and CISC architecture. Okay, so this is for RISC and this is for CISC. RISC only have consist of simple instructions. It have large number of instructions. It only utilize simple addressing modes. It has variety of addressing modes. It consists of a large number of registers. It requires a smaller number of registers. It requires only one clock cycle for execution time, which means each systems. So is the session is useful? Did you get any idea about what is embedded systems? What are the main things which are present in embedded systems? Everything? Can you please drop the replies in the chat box, please? Is the session is actually useful? Did you gain any knowledge on embedded system? How it actually works? What are the examples? Please drop your replies in the chat box. Yeah, Suresh, thank you for your response. Adesh, thank you. Yeah. So in later days, we will launch masterclass and NITK classes, everything. So if you have any interest or something in that, you can join the classes and get the good knowledge about embedded systems and everything and all. Okay. Yeah, we will provide a free masterclass and workshops on all these topics, embedded C, everything. So please communicate with the coordinator. They will provide you all the details about these courses and you will get make use of it. Okay. Saravanan. Yeah. Pratik, thank you. Shrishti, hi. So this is all about this introduction of embedded system on this free webinar on embedded system. So thank you all. Have a very great day.